today we are going to see different types of measuring instruments. Before this, we must know about the transducers and sensors. So first of all, we are going to see the transducer. So here transducer is a device which converts one form of energy into another form. It converts the input physical variable into a convenient and usable form of output. It is essentially based on cause and effect relationship. Now, sensor is an element of a system which first detect a measurement. For example, in case of a dial indicator, the spindle of a dial gauge is sensor, which senses the motion and converts into angular motion of the pointer. Sometimes sensors may also serve to transduce a measurement, and the unit is called as detector transducer. Means sometimes sensor has a function similar to transducers. Now, classification of transducers. Here transducers are classified on the basis of the nature of their operations. First one is resistance type transducer. Here there is change in resistance as the value of measurement changes. Similarly, capacitive transducer. Here change in capacitance takes place as measurement changes. Inductive transducer, there is change in self inductance due to change in measurement. And reluctance transducers. These are the main type of the transducers. Now we are going to see resistive transducer. It works on the principle that resistance of the any conductor can be changed by three different ways. That is, resistance is directly proportional to length, inversely proportional to area, and directly proportional to the resistivity of any conducting material. That's why this equation that R is equal to rho L by A. We can use first of all linear and angular resistance potentiometer. Here we use variable resistance, that is rheostat. This is resistive coil wound around the cylinder or core. Here voltage is supplied between these 2 points. This is input voltage, and output voltage is measured between 2 different points. So this is the movable pointer which is connected to rod. Here linear displacement is transferred to this pointer. That's why it will get moved. So here output voltage is measured between this pointer and negative potential. As pointer moves, the amount of resistance changes. Here in this position, current will flow through this pointer like this. You can see different positions of the pointer. So here linear motion of a rod causes change in resistance. As length of resistance increases, this change in resistance can be measured in terms of the change in voltage, and this is the working principle of the linear resistance type potentiometer. Now, second application, angular resistance potentiometer. Here this instrument can be used for the measurement of the angles or angular displacement. Working principle is very similar. This is the circular core and wire or coil wound around this core. Here same voltage is supplied between these 2 points, that is input voltage, and output voltage is measured between 2 different points. So here, similar to linear resistance potentiometer, here pointer is rotate about center, and due to this angular motion of this pointer, resistance changes and voltage is measured between this pointer and negative potential. You can see on a diagram. So this is the direction of current flows through pointer. Now same, as pointer rotates, resistance changes, and this change is measured in terms of the voltage. So here voltage is directly proportional to resistance, which is directly proportional to the motion. Here as length increases, voltage also increases. So we can plot output versus input graph, output on a y-axis and input on x-axis. So for this angular resistance potentiometer, what will happen? As pointer moves, resistance increases, also voltage increases. So here voltage is directly proportional to the angular motion of the pointer. That's why we got a linear relationship. So at a 360-degree, pointer suddenly reaches to zero resistance. That's why there is sudden drop in output voltage, and this happens after every rotation. Similarly, we can draw output versus input plot for linear resistance potentiometer. Here we know that as pointer moves, there is change in resistance, as also change in voltage, and this relationship is linear. Same principle can be used for pressure measurement. Now we are going to see how can we use this principle. So resistive type pressure measuring device. Here this is piston and cylinder arrangement. We know that as pressure increases, piston moves. So this is the inlet and outlet port. So as pressure rises, piston moves. So on the other side of the piston, if you provide spring, what will happen? As piston moves, spring will get compressed. So due to pressure rise, piston moves and spring get compressed, and it will stop to compress the spring when spring force becomes equal to the pressure forces. So at this point, movement will get stopped. So this displacement of the piston can be used for the measurement of the pressure. So as pressure increases, we know that spring force will get also increases. So as pressure increases, spring force also will get increase. So due to this pressure rise, there is a displacement of piston. If we transfer this displacement to movable pointer that is connected to the rheostat, what will happen? As it moves, the resistance changes, and due to this change in resistance, voltage also changes. So here we can say that the voltage changes due to change in pressure. So look into the diagram. Here pressure is, as pressure increases, piston moves, and this motion is transferred to the pointer. So finally, as pressure increases, displacement increases, then resistance increases, and finally due to resistance, voltage also increases. So we can measure the pressure in terms of the voltage.